and it's after lunch, which is like delicious lunch, right? I don't feel like speaking, but let's do it. No, I feel like speaking. How many of you guys know about the graph? Raise of hands. Oh, 5 people. Wow, that's a great progress. That should be good enough for us to really understand about how the graph works. Okay, I'll give you a little TLDR, a 1 minute thing. So we talked before this talk. We talked about the ZK, stuff, which is pretty cool. It is one of the focuses of the industry to put information inside the blockchain via layer 2s, via layer 1s, and to scale that. But how do we get that information from the blockchain to the user? That's called indexing, right? And the graph actually indexes data. If you have been a Web 2 developer, if you know how Web 2 works, then you might know that writing information inside database is important, and that's why Ethereum is important, layer 2s are important, all the polygons, minas, cellos of the world are important. But similarly, if you're writing data inside the blockchain, you need information to read that, you need infrastructure to read that information from the blockchain too. So the graph is a middleware between the blockchain database and your front end. It's a middleware to get the information from the blockchain to your world, right? And basically, we have iterated through a lot of times to understand how you can get the information from the blockchain. As of now, the standard is you actually have a RPC, you actually query that particular RPC, and get the event data and event information. But that's not very efficient, because in smart contract you write events. Events make your particular transaction and your particular smart contract get a lot of gas, right? For example, if your transaction would have costed $2, it would cost $2.5. So putting events inside a particular smart contract is not efficient, first of all. And the second biggest issue is that it's very slow. If you want archive data RPC, it's very, very slow. It's very, very tough. And given that we are the biggest nerds in world in the blockchain, we try to make things more efficient, because imagine if there are 100 million people on the blockchain, you might be able to write information with all the layer 2 scaling happening, but you will not be able to get the information. And if you cannot get the information, then it's of no worth, right? It's like Instagram, where you can post pictures, but you cannot see the pictures. So that's why we innovated on the RPC stuff and got this new indexing standard known as Firehose. So how does Firehose works? How does the current graph infrastructure works? It's like a ETL queue. Extract, then you transform, then you query it. That's it. ETL queue. Extract, transform, load, and query. Extract, transform, load, and query. This is all linear way of indexing data. You get the information from the blockchain, transform it into what you want, then load that information in database, and then query that information. Extract, transform, load, and query. But that's not really a very scalable way. Why? Because this is very linear. If you have an event which has a lot of data, you'll have to go through this linear path of first extracting the data, then transforming, then the loading into a database, and then querying that information. How do you make this efficient? The answer for all the computer science graduates is parallelizing the process. Extraction should be parallelized, loading should be parallelized, and all of these things should happen in one go, in one thread, right? It could be multi-threaded infrastructure, and that's what the graph actually built. So I already talked about what are the problems with the RPC, but the solution, as we talked about, is Firehose. For extraction, you need, if you want innovation in indexing, you have to innovate in all these 4 processes. Extraction should be much more efficient. Transformation should be much more efficient. Loading should be much more efficient. And then querying that information should be as efficient. As a computer science person, you have to parallelize these processes, and each process needs to be very, 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 very nicely efficient in all the ways. And right now, the extraction is not efficient. The RPCs, the Infuras, the Alchemies of the world are not very efficient. And the reason I told you is that they rely on event indexing to get you the need that's required. You cannot do that. For example, if you want information about an CryptoKitty event you did in 2017, that RPC will be calling all the events of the CryptoKitty smart contract from 2022 to 2017. That's like 5 years. to get you that information. That's not efficient. So the answer to the RPC latency issue and the cost issues and the performance issues is Firehose. What is basically Firehose? Firehose is flat files. Instead of using RPC to make a blockchain data available to you, you use something like Firehose to make that data flat. So you still get the information from a file from the blockchain data, but it is very, very flat. What are the benefits of Firehose? It is basically a flat file. You run a blockchain full node, let's say Polygon full node, get the information and store it in flat files. It enables parallel computing, like we were talking about. ETLQ is all parallelized, and the last one is that it's blockchain agnostic. So right now, all the RPC stuff we have is all EVM, right? But there are other blockchains like Near, which are not EVM. There are blockchains like Solana. There are other blockchains in the world which are not EVM. How do you create a standard for them? Do you create an indexer for all the new chains that up and come? No. You make sure you have a database standard so you don't have to keep on innovating and creating new indexers. You make sure your indexer fetches information from a generic data, and that's Firehose. So basically, if you're creating a blockchain, you don't have to worry about indexing. All you have to worry about is making your blockchain compatible with Firehose. So basically, a particular blockchain, anybody can be compatible with the graph if they are compatible with Firehose. They don't have to create a new indexing standard if they are compatible with Firehose. So how does the Firehose architecture actually works, right? It's a full node which reads information from a reader. Reader takes the information from the full node, right? And then it creates a single block file. That single block file is either consumed by indexer if it's the latest information, or it is going inside the object store for getting the information stored, right? That's how flat files are created. You have a block that's created that is converted to a flat file. That flat file is either used by indexer, or it is, first of all the useful information is taken and the flat file is deleted. That's how the architecture of Firehose works. And to make your blockchain efficient and compatible, all you have to do is you have to just make your stuff compatible with Firehose. Basically, you have to make your blockchain, let's say Near blockchain, compatible with the reader. That's all that's required. What are the benefits of Firehose? Why would you want to do it? Because you want the graph to index your blockchain. You want an indexer to get your information from the blockchain to the front end, right? And we have had so many inquiries of, let's say, Near and Solana and all those people who want their information to be indexed by the graph standard. Up till now, we could not do this because we were relying on RPCs for getting the information. But now we can, because we have created this new standards, which is not RPCs, rather it's Firehose. So with Firehose, you can get your blockchain compatible with the graph, first of all. Secondly, it can power substreams, right? And I was talking about the ETLQ. Extraction is Firehose. Transformation is substreams. Transformation is the one which makes your information more efficient. You have the raw information already. How do you transform it into what you want? That's done via something called as substreams. And the results we have got from substreams are crazy. Up till now, PancakeSwap, Uniswap, all the big dexes used to exist on the graph. But we had these complaints from all the fast chains and for all the fast dexes that the graph is not fast enough. If it's not fast enough, it cannot keep up with the blockchain. If it cannot keep up with the blockchain, it takes a huge time to sync. So right now, if I start on the graph node and start indexing Uniswap subgraph like a thing, from scratch, it would take 2 months until I can get the information. That's not efficient. In 2 months, anything can happen in Web3. That's not the right way to make things work. What's better is basically you make something like Substream. With Substream and the Firehose combined, the parallel ETLQ model, we were able to make the 2-month indexing, the 2-month data retrieval processing, all these things happen in 20 hours. And that's what the graphs new beauty is you have Firehose, you have substreams to get your complicated, fast chain information indexed from 2 months in 2 hours. So all we require all the chains is to integrate with Firehose architecture, and they will have the fastest indexing in the world. So you need, if you have, let's say, Starkware, right? You have a Starkware node and you want to make it compatible with the graph. What you do is you enable your Starkware client with Firehose, right? That can actually take information via graph node and give you the right information in API key that's required. As of now, we have already started building on it. It's not, something in stealth that we are doing. It's already live in production. And these three beautiful, dApps run by Maheshwari are being indexed by the graph. So via substreams and Firehose. So Maheshwari Uniswap has a subgraph which is being indexed by, and queried by the Maheshwari team to show their analytics page for all the data. That has a substream subgraph, right? So it's already in production, it's already live. And as I told you, we did this experiment of indexing blockchain data with Uniswap, with our current subgraph standard, and then with the substream standard. And with the substream standard, we were able to do it in 20 hours. So that's what we think is the future. It's already live battle tested on the hosted service. To try it out, all the hosted service Ethereum subgraphs are powered by Firehose. So you should all try it out. CTA or call to action for all the chains that exist in the world right now is that make Firehose a standard in your graph node, in your chain client node. So if you have a new chain coming up, which is going to be the future of Web3, I mean, that's what most chains claim when they come up. And and it might be, right? We want to believe in you. If you want to do that, if that's what you think will be the future, then have Firehose integrated in your client so that it is compatible with graph node, and we can do the indexing for you for your dApps. So that's about it. This is how the architecture works. I don't want to bore you into the details of the stuff. But yeah, we already have some progress. Ethereum guys, one of the core teams, which is ChainSafe, which also maintains the Aragon client right now, has worked with the Graph Foundation to have the Aragon implementation of Firehose. So basically the Aragon Firehose is right now live, and you can see it on the Graph dashboard as well as in this particular article. But we have already made progress with Ethereum and EVM chains we are already talking to. There is Multis, which is another important chain in the European region right now, and they are pretty predominant there. They have integrated with Firehose, and there are a few others that we are talking to right now, which are EVM, who want to integrate with Firehose, and they can do it with the current infrastructure. That's about it. That's Firehose standard for indexing blockchain data. If you have any further questions, you can either ask me on Telegram or tweet about how good a speaker I am on Twitter. It's time to clap.